Hello students, welcome to Saurabh's classes. In this video, I'll be talking about control charts. So, in industrial statistics, control chart plays a very important role. Now, there are few parts of which a control charts is consist of. So, few parts of control charts, I will need to tell you about this. These are point number 1. Points representing a statistic. Points representing a statistic. That is like mean, range, proportion, etc. of measurements of a quality characteristic in the sample taken from the process at different times. Also, it depends on, it has a part where the mean of the statistic using all the samples is calculated. Mean of the stat using all samples are calculated. That is, you have to calculate the mean of means, the mean of ranges, the mean of proportions, etc. Now, the central line is drawn at the value of mean of the statistic. Central line for the value of mean of the statistic. Then there will be a standard deviation, the SD of the statistic, which is also to be calculated from the sample. There are upper and lower control limits. I already told about upper and lower control limits in the previous video of SPC and all, UCL and LCL. There are upper and lower warning or control limits. Upper and lower warning or control limits. Then there is division into zones, division into zones, governing with rules governing the frequency observations in each zone. There will be annotation with events of interest, and this event of interest, as you know, is of course determined by the quality engineer in charge of the process quality. There is action on special cause. Now, you know that there are several rules sets for detection of signal. If there is any kind of problem occurring in case of product or when they are producing the product, if there are some kinds of problem occurring, there are a set of rules. There are several rules which are set for the detection of the defect signal. Now, I will talk about such a set of rules. This is only one set I will be talking about. Point number 1 is any point outside any point outside the control limits is accepted as defect. A run of seven points, all above or all below the central line, this is also a defect, and they will stop the production as soon as they actually come up with this fault. And third is when these 7 points all above or all below occurs and the defect is already there and they already have detected the defect in the product system or production system, they stop the production and then they run a few tests. These tests are, one is quarantine and 100% check. Then there is adjust process. Point number 3 is checking 5 consecutive samples. Checking 5 consecutive samples, then continue the process. Now I'll be talking about the choice of limits of the control charts. Choice of limits of the control charts. Now the choice of limits has a very name or very fashionable name, you can say, that is Shewhart 3 sigma Shewhart 3 sigma set or 3 standard deviation. And now I will be discussing in detail why it is Shewhart 3 sigma set. Here the 3 choices are used. First is the course result of Chebyshev's inequality. Chebyshev's inequality. You all know Chebyshev's inequality. If you don't know, in that case, I'll talk about it. Chebyshev's inequality is that for any probability distribution, the probability of an outcome greater than k standard deviations from the mean is at most 1 by k square. Now there is another use of the final result of Wyshensky and Petunin inequality. So final result of Wyshensky and Petunin inequality In case you don't know what this is, I'll tell you that for any unimodal probability distribution, the probability of an outcome greater than k standard deviations from the mean is at most 4/9k square. And there is another rule that is about normal distribution. It's a very common probability distribution, and in the normal distribution 99.7% of the observations occur with 3 standard deviations of the mean. Now I'll be talking about different charts, that is different control charts like X and R chart, X and S chart. So let's start with that. First I'll be talking about X and R chart, X bar and R chart. X bar and R charts are also known as mean and range chart. And they are commonly used in dealing with variable data to monitor the quality of a manufacturing process. So here X bar is the average of subgroup average, that is the central line in the chart. X bar L is equals to average of the ith subgroup. N is number of subgroups. R bar will be average of subgroup range. For X bar chart, UCL is equals to X double bar plus A2 R bar, and LCL is equals to X double bar minus A2 R bar. And for R chart, UCL is equals to D4 R bar and LCL equals to D3 R bar. Now I'll be talking about X bar and S chart. These two charts are very important and much more discussed than other charts, X bar and S charts. This is very similar to X bar and R chart, but in this case it is just a mean and standard deviation chart, mean and SD chart. The denotations are the same as the above. So here for X bar chart, UCL is equals to X double bar plus A3 S bar, and LCL equals to X double bar minus A3 S bar. And for S chart, UCL is equals to B4 S bar and LCL equals to B3 S bar. there is another chart I want to talk about, that is C and U chart. C and U chart. What is C and U chart? Before discussing C and U chart, I need to tell you about P and NP charts. Then it will be easier for you. P and NP charts. P and NP charts are for discrete attribute data. Discrete attribute data. P charts and NP charts, these are ideal for this data. P and NP charts are ideal for this kind of data. Now, attribute data is for measures. It is for measures that categorizes or bucket items. That categorizes or bucket items. Let me add a page. So this helps so that a proportion of items in a certain category can be calculated. Thus, P chart is useful for when a control chart of these proportions is desired. When a control chart of these proportions is desired. And NP chart is approximate when the number of the items used to calculate each proportion is same. NP chart is appropriate when number of items used to calculate each proportion is same. For example, if there are 100 reports which are reviewed each week and they are categorized as accurate and inaccurate, the proportion of inaccurate reports could be plotted on a P chart, or the actual number of inaccurate reports could be plotted on an NP chart. Now, control limits of P chart. UCLP is P bar plus 3 root over P bar multiplied by 1 minus P bar by n. LCLP is equals to P bar minus 3 root over P bar multiplied by 1 minus P bar by n. And for NP charts, UCLNP is equals to NP bar plus 3 root over NP bar multiplied by 1 minus P bar, and LCLNP is equals to NP bar minus 3 root over NP bar multiplied by 1 minus P bar, where n is the subgroup size and P bar is the average fractional defectives. Now, C and U chart. C and U chart are very similar to P and NP charts, and in that it requires equal sample sizes for each data point. C chart requires equal sample size for each data point. For example, in evaluating error on loan applications, when you are evaluating these errors, you would be able to use this chart if you sample the same number of applications each week. That is, you have to check the same numbers of applications every week. But instead of plotting the proportion of a data in a certain category, like you do in NP chart, the C chart plots count data such as number of errors, or as the other control chart, special cause tests use check for outliers or process trips. That is, when you are using the NP charts, you get the ratio in NP charts, that is a ratio of some kind of data and all. But when you are using the C chart, you will get the exact number of the certain category of data. Now we will be talking about the control limits of it. The control limits, that is LCLC is equals to C bar minus 3 root over C bar, and UCLC is equals to C bar plus 3 root over C bar. U chart is a more general version of the C chart for the use when the data points do not come from equal sized samples. So U chart is a generalized version of C chart, generalized version of C chart. So the truth is, when you are using C chart, you always have equal sized samples. But if you do not have equal sized samples, then you cannot use C chart. Then you will have to use U chart. So U chart for not equal sized sample, equal sized samples. Like when you are reviewing the loan applications each week, the number of the applications submitted each week or reviewed each week may differ, and in that case you will have to use the U chart. So U chart also has control limits. LCLU is equals to U bar minus 3 root over U bar by N, and UCLU is equals to U bar plus 3 root over U bar by N. So here U bar is the average number of defects per inspection unit, and C bar is the average number of defective, and N is the number of inspection units. Well, this is all about control charts. We discussed 4 types of control charts. One is X bar and R chart. Another is X bar and S chart, that is mean and range, mean and standard deviation chart. There is also P and NP charts. P and NP charts are mainly for the calculating ratio of some kind of data, and then there is C chart. C chart is nothing but the calculating the exact number of data, which is impossible in NP charts. In NP charts you get the ratio, but in C chart you get the exact number of the desired data. And then there is U chart. U chart is a generalized version of C chart. When you are using P chart, NP chart or C chart, you always need to use equal size samples. Like when you are reviewing loan cases, in each week you must have to check equal number of applications. But in case of any mishap occurs, that is in case of checking loan applications, if every week the number of reviewed applications are not same, then you get a non-equal size sample. So in this case of samples which are not equal, we use U chart. So for not equal size sample, we will be using U charts. These are the important control charts we will be needing in industrial statistics. Well, thank you for watching the video. Hope this help you in brushing up your concepts for your UPSC and ISS entrance of statistics. Thank you for watching again, and you can keep checking our channel for more videos on this. You will also be getting the solution papers of ISS there. Thank you.